Okay, so what is an API? It's a group of function specifications that together provide a service to some programs. And those programs that use the API are called clients. And data encapsulation turns out to be really important here. We want to encapsulate the implementation of these API functions. So the client has to use the API. So the API then will be a complete description of what can be done with this service. Okay? So it simplifies our life a lot. Okay. So here's a picture supposed to show that, where the client is going through the API in order to use the service. Okay. Now we even use this idea in C. We have like string copy and string compare in the C library, and you can't really see how they work, but they do work, and that's an encapsulation. And we can have, if you go to the beginning of our textbook and look at section 1.2, there's an example of an encapsulated counter.java that is used by flips.java. So the flips.java is the client and counter is the service in this case. So you might review that example. So the idea here is that you can't jump over and use the implementation details or the class variables directly. You have to go through the API. Okay. So there are various advantages of encapsulation. So we're definitely going to be using this all the way through. So it gives us a clear statement of what we can do. It also partitions the responsibility. So if you have two teams of programmers and they're working on a system, what's really important is the API between them, between their bodies of code. So that can be, something they fight over as they're doing the design, and finally they get all the responsibilities on the right side, and hopefully happily live happily ever after. But of course, that's not quite true what happens, but that's the theory. Okay. So once you have an API, then you can use them in more different ways. We're always trying to reuse code, and we don't reuse as much as we would like, but still it's a goal. Okay. And another thing is that it makes the contents more safe if you have to go through the API to change them, and that's really important in debuggability. You can breakpoint the API and catch it on the way in to changing your data, so you can figure out what's going on. It doesn't, if you don't have encapsulation, a memory reference can go and destroy part of your crucial data as it runs. And this is particularly common in C, because C has pointers, and pointers can point anywhere. So Java is a little bit better even without encapsulation, but still, encapsulation helps a lot, even in Java. Okay, so the API is this group of function specifications that shows what you can do and how you can call into the system. So that's what we'll call an API, is nice and short. And the only problem with the term API is it has another meaning, and that is a system of network calls. And that is usually called a REST API. But sometimes they just say an API. So when you hear the word API in the wild, you have to figure out, is it a function spec or is it a network spec? But we'll just be worried about the function case. And there's a big relationship between the two of them. They're not that much different, but still they're a little different. Okay. Any questions on this setup? Okay. Okay, so here is a class that you used last term if you were in CS210 in Project 5. Okay, so you had a point 2D, or a two-dimensional point. So you could create a point at 3, 4 by saying either P1 equals new point 2D of 3 and 4. Okay, and you can create another point, and then you can ask those points for their coordinates, like that would be x1 here, x1 equals p1 dot x of, as a calling the x function, and that will give the x coordinate back again. Okay, so that's using the API of point 2D. There's a method called x, and similar to that method called y that returns the y coordinate. And you can also compute the distance between the 2 points by p distance 2. And you can convert to polar coordinates as well using the theta function and the r function. Okay, so theta is another method of the API, and so is r. Okay. So the API is going to gang together all these different methods, and the API, using the definition of API in the textbook, the API also includes the constructors. Okay. So you see that the class that we're describing probably contains the x and y coordinates of the point. That's the simplest explanation. Of course, it could equivalently hold the radius and theta of the point, but it needs to have a different value for every point. So x and y would be the simplest way. So it's going to look like this. And of course, this is just copied out of the book. It has private data that holds the x and y coordinates. And then it has a constructor that takes in the x and y coordinates to make a point. You know why they have a 1 here. And then, of course, x, the method x returns the x coordinate, and the method y returns the y coordinate, and the distance 2 has to compute the distance between those two. So there's actual code in here. And there could be private methods as well. Okay. So this is, hopefully you've seen this example. If not, this is covered in the book as an example. And so it's a nice little neat example with a simple API. Okay, so here is page 77. Shows the API as written in the form that is used by our textbook all the way through. Okay, so there's a public class point 2D, the top level, and then the constructor shows, it's a little bit off kilter, I guess, but, and then we have the various methods here, and these are all going to be public methods. We go back, look at the code. Those are public, right? We don't bother with any private methods when we talk about the API, because the API is what you could call from the outside world into this class. Okay? You notice that this setup is quite useful as a programming aid, but it's not compilable by Java. It's just something for us programmers to refer to while we're doing our code. Okay. So that's what is meant by an API. So we'll stick to this definition, what an API should be. But we want to make it to, this should be point, of course. Oops. Ah. I went the wrong way. It should be 0.2 dim. We can make a public interface out of this, out of these methods. Okay, so it looks like this. We just list all the public methods, but not the constructor. Okay, so this is an interface doesn't have the full API in the sense of the book. Okay, so but we get the advantage of this setup is that it is compilable. So this is something we can check with the Java compiler, and we can use it in more ways. Right? So this is and by itself, it is a very useful summary of the class. So it just doesn't have a constructor. Any questions on the basic setup?
You said the interface is a summary of the class. What does it not include apart from the constructor?
Well, all the code. You see, it's just like the API. It only has the function headers, not the code.
I understand that. Are there specific methods that it doesn't include?
Well, private
Okay.
methods would be not there. So you can have constants. You could put the constants in the interface, although some people think it's not a good idea. Okay, so this is our first example of an interface. Now, to make it really usable, we need to link together the concrete class, the one that has the code in it, and this interface that we've come up with. And the way you do it is by adding this implements point2dim in the class code function, the class itself. So here's the private double, so we can tell it's really a class here because it has data in it and has code in here. We don't have to show very much of it, but you can imagine all the code there. And it could have private methods in here as well. So, so this is only saying that it has these, the double X, double Y, and a few other things. I guess I don't have the theta here, but theta's there in the whole thing. Okay. So you can see that all the methods of the interface are methods of the class. That's required. But you can have, the class can have additional methods and of course, real data in it. Okay. Any questions on that? Okay, so this links together the class code and the interface code. Okay, well, what is it good for? Well, you can use it as a type in your program, and it's a more abstract type than just point2d would be. Okay, so here's a really quick example. I'm just calling this point2dim p1. So this is the interface type, and in order to get something real, I have to use a constructor, and the constructor, of course, is part of the class. So I have to go to the class, the concrete class, in order to get going. So this is typical, where we have the concrete class giving us an object, and that gives us an object reference, which we put in a variable of this slightly more abstract type. Okay? So P1 is this point2dim. But what can we do with it then? Well, we can still use all the interface methods with P1. So we can call X using P1. Okay. So you can see that the system, of course, still has the reference here. We've just changed the type of the reference. It's still pointing to this real thing, this real object that was created by point2d. So it's perfectly possible to call X, and this routes it to the X function of the concrete class. Right? So we get back the actual value that belongs to that object. Okay, so we're just giving it a slightly more abstract name here. And
by saying it's the interface, do you lose access to the methods of the real class?
Well, some of them, but which ones are you worried about? The public ones are the ones, well, if your interface is very narrow, yes, you do lose access to the ones that aren't in the interface. But this case, we have point2dim has all the public methods, so we don't really miss out much, right? But if it was really missing theta, for example, then we wouldn't be able to call p1.theta. We can only call interface methods through the interface variable.
I'm still a little confused about the purpose of the interface if we could just instantiate an object of the class directly, you know?
We have new point 2D. That's we've instantiated a point. Well, I
Okay.
haven't really showed you an advantage of this. Our
Okay, cool.
first goal was to just look at how you can do it at all. Okay. And now we need to explore further to see what it's good for, right? Okay.
Good question. Good question.
Yeah.
So like when you like comparators, those are also interfaces.
Yes, comparable is an interface.
Right.
And you use that when all the sorting classes were had comparable arguments, right? Array of comparable.
Right.
So you've seen that, but you know, in the book sort of slides over this whole thing about interfaces. So we need to, you know, be careful in trying to build up the knowledge about it. Because even though you've been using interfaces, it's not with, you know, looking at them very hard. I mean, this whole book is about doing all these algorithms with any language. By the way, we're going to use Java in this book, but, you know, so they try to avoid anything about the language itself. So anyway, let's go on here. And so here, of course, you can say, why have we done this? We had a perfectly good type before. We've just invented this slightly more abstract type. Why would you do this? Well, maybe you won't. We don't do this with a lot of classes, but let's try to imagine a case where this would be actually useful. So let's suppose we have two different, we're interfacing between two different point classes. So we have another class called point XY, which has different details in the concrete class. You know, it's holding things a different way, but it has the same API. Okay. Now, so we could say that they both implement this API. And then we could write what's called generic code. We can write code that can treat them equivalently. So let's see how that works. See, we have 0.2dim P1 here equals new 0.2d of xy of 2, 3, right? And another point made out of point xy. But now we've managed to have them in one type of point. P1 and P2 are much closer together, much more interoperable. And in fact, you can do P1 dot distance to P2. So you could have points coming in from two applications with slightly different details, but you can still program with them. So you get this interoperability. Okay, then you could say, well, you had to stretch pretty far to come up with this example. I admit that. But this is the kind of thing we can do. So that's why I admit that here. We don't often need to use two kinds of 2D points. So we don't bother with interfaces for a lot of little objects like this, like points. If everybody agrees what a point is in the whole application, well, it doesn't need an interface.
Excuse me?
Yeah.
Would 0.2dim have to implement point XY and 0.2D in order for you to be able to use both of them?
Well, it goes the other way. That the concrete classes would each have to implement 0.2dim.
Okay, that makes sense. And they'd have like more instance variables by themselves too.
Yeah, they could have, one could be an R theta representation and the other an XY representation, for example.
Okay, that makes sense.
You could have interoperability, and that means that when you ask for X in the theta driven point, it has to convert from R and theta to X, and similarly on the other side, it'd have to convert if you ask for theta. But
Okay,
it would produce the right values, and the client wouldn't care, right, where they came from, as long as they know the R and theta of a point. That's all I need.
Wait, but in this example, if one is in terms of r and theta and the other in terms of x and y, how then can you instantiate them as the same type of object?
Well, let's go back to the code again, because that's, see what we've done here. You have, whenever you need to create an object, you always have to go to the concrete class. That's the only way to do it.
Mhm.
So we're going to see, this is like, we're going to see the first new using concrete class. In this case, 2 different concrete classes.
Mhm.
And then we have a common type, and then we can work with them together as the same interface type.
And then that interface has its own set of attributes or methods that must be able to correspond to the 2 distinct classes.
Well, watch out, you can't have any data in an interface.
Okay.
You only can have, it's very, very lightweight. You can only have the headers of the functions, methods, the public methods. And
If you need
constants.
if you need another example of that, comparable is a good one to look at, where an interface basically will mark common behavior between classes.
Yes.
But but each object has to be compared differently depending on the object.
Sorry, I didn't hear that. Can you say that a little
sorry.
louder?
Like when you're writing a compare to method in comparable, you have to define it on a object by object, on a class by class basis, because some objects may be compared in different ways. So that's why you can only have the header and not the function definition in the abstract.
Sorry, I still didn't hear all of that.
You can only have the header and not the function definition because why? Can you repeat that?
It's a very general case. For example, say you have a class that represents a deck of cards, or rather a card, and you can have an array that would make a deck of cards. How you sort a deck of cards might be different from how you sort something else. And that's why you'd have to write like a different kind of compare to method depending on what you're working with.
Right. And so where is that method held if not the interface that compares different types of classes?
So an interface defines the header or the function definition of class.
The interface says you have to have that method, but you
Right.
implement it in the class.
Okay.
Right.
Exactly. So when you implement a method, you are forced to write the definition for the method in the concrete class.
Cool. Thank you.
Okay, so let's see how this goes. Now, okay, so this, of course, is somewhat of a stretch, but we want to be able to use interfaces for serious classes, okay, because we want to look at these container classes and things like the symbol table, which we will call map, following the JDK nomenclature. Okay. And now the book is quite strong on generics. It uses generics in a consistent way. And that's very helpful for container classes. So I hope you're very comfortable with things like this public class Q of item. There's a generic variable there to, so this Q can hold any kind of element object. Okay. So that's so we're kind of assuming that that's already covered. Okay, so you see that what we want to do is gloss over 2 different implementations of the same service, or so the same API. And so an obvious example is the symbol table that you studied in CS210. And this was captured in the project 5 that we were just talking about. And you had a symbol table called array ST and the red black VST, and I think also a KD tree. Okay, so you had different implementations of a symbol table in the same project. And in fact, there was an interface called basic ST that was used in that project. But I don't know if you noticed, but that was not from the textbook. That was made up by Swami to begin to show you the power of interfaces, I believe. Okay. So by looking at basic ST, you can see the essential characteristics of all those different implementations, what they're really doing. Okay. So we're going to continue this effort that was started. Any questions on that? Okay, so this is involved with type compatibility, right? And so you see we've got one type here and another type here. This is actually a subtype of this one. And so we have assignment of a one type object to another type variable. But we know that Java uses strong typing. So you can't mix things. You can't have apples equals oranges in Java, because, well, it shows that it allows this because it considers the 0.2D to be a subtype of 0.2dim. So 0.2dim is the more abstract type here. So it has a subtyping mechanism in it. And you can see that it has to know this for sure, and that the way it knows it is it parses that source file for the class and sees the implements .2dim, and that's its key to know that the two types are linked together this way, and so it's all right to have a P1, this .2dim P1, equal to the new .2D. Okay. So we can say, using the object-oriented terminology, we can say that .2D is a 0.2dim as in types.
Is Java's subtyping mechanism an expression of an interface?
Well, interface is a mechanism for subtyping,
Okay.
as is subclassing. Okay, so there's two forms of subtyping in Java: interfaces and subclasses. And we're going to be doing the interfaces first. Okay, so you don't have to worry about subclasses yet, but we do want to cover subclasses later on. Okay. Okay, so that's expressed here in a moment. Okay, so you have been using type compatibility using the textbook. So as we mentioned earlier, comparable. You use comparable in chapter 2 in the sorting, showing how you can implement a function that sorts an array of comparable, and then you can use that function to sort all kinds of objects as long as the objects individually are comparable. Okay, so there was the example that they have there is a date object. It's not the same thing as a JDK date, but a date object that represents a date, and it is comparable and therefore can be sorted. So you take an array of dates and sort them with any of those sort methods in chapter 2. Now, what does it mean that date is comparable? Well, it means it has a compare to function. So that's the key. So that when Java knows that it has a compare to function, because it is comparable, then it can call it to compare the individual elements and sort them all out. Yeah. So that's kind of type compatibility, where there's an interface comparable, and then date implements comparable. So date is sortable in chapter 2. Okay, so that's one example of type compatibility that you've seen in use. And another one is sort of more specific, but I think you might have possibly have been confused by it if you tried to understand it before. But there's this code for keys for a symbol table, and if you look on the page on page 382, so keys is one of the methods of symbol table, and in this case, the way that the concrete class answers keys, makes up something to respond to the keys request, is it creates a queue and passes it back. Just here it is. Here's the queue. But the caller doesn't know it's a queue. The caller only knows it's an iterable. Well, that's enough to satisfy the API because the API has just said it's an interval. So that means that you can iterate through it. Okay, but you can't do the other queue methods. So that's a case where the interface is really restricting what you can do with the object. Okay. So this all works because a queue is an iterable, and queue implements iterable. Okay. So that's sort of a strong use of this idea. Any questions on that? Maybe you didn't notice that anyway, so, but it's true. And there's another case of this VSD, something like the sort case. The key is a comparable. So you can see that the various container classes that are being implemented in the textbook are not themselves in the JDK. They're all, separately coded by the authors, and they're competently coded. I'm not complaining about the code. It's just that we should also know the JDK, and the JDK has even more powerful APIs. So they're worth study. So we're going to do that. But these two interfaces we're talking about, iterable and comparable, are from the JDK. So the authors took the interfaces, but then rewrote all the concrete classes. And we'll see other interfaces in JDK. Any questions on that? Okay, well, let's look at a different example. Here's sort of the classic object-oriented first example is the bank account. Okay, so you construct a bank account, a name and an ID and a balance. And so you get this bank account. It should be spelled out probably. And then when you have it, you can modify it. So this is a little more ambitious than the point. The points weren't mutable, but these are. And of course, when you access, you want to get the balance from the BA, the object, you mustn't try to get it directly. That would be wrong. It wouldn't even compile, because that's the beauty of using Java. As long as you make the fields private, this won't even compile. So it tells you that it's not right. But anyway, the right way to do it is to call through the API. So we have get balance to get the balance back out of the bank account. Okay. So you can see again, we say the API is telling us what methods can be used with this object. Okay, so here's the interface for that. So you can see that again. You don't put the public keyword in here, but because it's in an interface, it must be public. The whole thing. This is about whether the whole thing is private or public. You can have a private interface inside a class. Okay. So one thing that we must know about it is that you can't instantiate it. We can't say new account because it doesn't really have the whole thing. It doesn't have the code. All it has is the idea of it. So it's too abstract to be instantiated. So that means, as usual, what we have to do is get a concrete class that implements account, and then we can do a new on that class and get a real object. Okay. So again, we're going to see that a class will implement this interface. It provides code for all these methods, right? And of course probably has to have a constructor too. It's not required to have a constructor, but usually we like to have a constructor. Any question on that? Okay, so here we have the bank account that implements account. Here's the constructor. And here we have the various API functions. And here we have the fields. I usually like to put the fields first, but other people like to have them last, so I try to be tolerable about that. All right. Any questions on that? Okay. So now let's, we see that bank account is an account, and we can have, this is a simple way of doing things. You just have a bank account variable. This is the constructor. So we're creating the bank account object by going to the concrete class, calling a constructor, and then we can use it. But we can also go, once we have it constructed, we can drop it in an account variable. And we can still do these important actions because they're in the interface. Any questions on that? Okay. So here's some, the general case. I'm going to write it out. So class, there's a lot of different terminology here. There's ISA, and there's subtype, and so on. So, and type compatibility. So it's a little bit tricky to keep it all straight. But I'm trying to make it clear here. So yeah, class A is a B. A is the same type as B, or A's class implements B and interface. That's leaving out subclassing because that's what's down here in this comment. But we will eventually going to talk about the fact that you can have a class for a subtype of another type by being a subclass. But we'll keep it simple now because we don't want to consider subclasses. Okay, so we just have interfaces doing the work. Now, A is a B sounds kind of symmetric, but it's not a symmetric relationship. So you have to watch out. So if A is a B, then we say A is type compatible with B, and we can assign B equals A, where A is an A and B is a B. So you can see an object B can refer to a B, of course, or any type that is a B. So there's that flexibility that you can have an object reference that can be pointed at various subtypes. So that allows you to have this generic programming. So you could have like an animal interface and have a dog and a cat and a bear, as different animals, but each having their own class. But then you could have an array of animals, and then you could do generic programming, generic code across that. So you could, what can animals do in common? Well, obviously they can eat and other things. So you can make a little interface, and then to feed them all, you can just eat across the array. Okay, so that's the kind of thing we're talking about here. Now you can actually ask Java about this. But there's instance of operator. And so it's all lowercase. You might think it would be camel case, but it isn't. And but we don't like to use this. You see a lot of instance of in code that's usually bad code. So you try to write code that's clear and doesn't have to use that. But every once in a while, it is useful. Any questions on this? However, we said we wouldn't cover subclasses, but there is one subclass relationship that is important and we need to deal with it. And that is the fact that every class is a subclass of object. So object is the class, the one that sits above everything. And since that's true, we need to know about it. So every class A is an object. And so that means that, for example, we can say object X equals A for any class object can be. But it's not usually a good idea because once you start calling it an X, you really don't know anything about it. You can't call any useful methods on it because the object is just the bare bones things that has equals and so on. There's homework on that. Okay, but it's important to know this relationship because we can use the object methods because these are available on any object, since any object is a subclass of objects. So equals, hash code, and toString are the most commonly used ones. But we're going to be using still another one called getClass when we implement equals. Okay, so these four methods are very useful. So let's consider an example. Okay, so here's bank account again. This is the same thing as before. And you notice that there are no methods named equals, hash code, toString, or getClass. You don't need to code getClass. This Java takes care of that. But these could be there, but they aren't. Okay, and that's perfectly okay. You know, we don't want to do any extra work that we don't need. If we don't need to code equals, we just don't do it. And we'll talk more about this when we do want to do this, but this is fine. Okay. But it's going to be there. We can call toString on BA, this bank account class. I should have said, maybe I should have bank account there. Put bank here, bank account BA, because we have to go to the object here to ask for the toString, it's not going to be in the interface. So that was a mistake. So I'll fix this slide. Anyway, when we work with the object, it's going to have toString because the bank account is an object. Okay, but I actually ran this code and it works. So I guess even with the interface, it works. So this, well, I have to look and make sure that it's the same. I put this code in, or what I think is the same code, in the bank account directory. So you have a zip file. You can try this out. Okay, so what do you get? Well, nothing very useful. Here's the output I got from my test bank account. All you get is the name of the class and the memory location. So it's not very useful, but I'm just trying to show the theory of it here, that the object methods are available on any object. But it'll turn out that equals and hash code can be used with hash map and other important classes in JDK. So we'll come back to using this. Okay. Any questions on this? Okay, so you know about the object methods and how they're always available as long as you have a proper object. Now, just to finish this topic up, we've been talking about object types and types in general, but of course you mustn't forget about the primitive types. They're very useful, very compact, efficient. That's why they're there. And how do we work with them if we want to use objects? Well, every primitive type has a corresponding object type. It's very easy to go from one to the other. So it's called auto-boxing, and it's described here in the textbook. So here's an example. We can take an integer object. This is a literal for the int 10, but it's auto-boxed into this object I. Okay. Any questions on that? Okay, hope everybody knows that. Okay, so that's the end of that thing, but we have another slide set. Let's get the other file. Here. Okay, so we want to get started on the JDK classes. Okay, so these are the collection classes that we have available in the Java system. So a collection, of course, is just a container of objects, which could be ordered or unordered, and it may or may not allow duplicates. So that's pretty vague. What we want to do is see the various interfaces that are and concrete classes that are available in the JDK. Okay, so we're going to look at sets and maps first because they have the easiest API, and then look at lists and stacks and queues and priority queues. Now, of course, because we're looking at the JDK, we don't have the use of the textbook for this. If you have Weiss, there's a good chapter 6 on this. But you also, of course, can look at the JDK API, Java docs online. They're very useful. Okay, so even though the details are different, the collection abstractions are covered. So the stacks and queues and priority queues and symbol tables, which we're going to be calling maps now, but they're the same thing. And even sets are briefly covered in the textbook as specialized symbol tables. Because the symbol table, if you look at the domain of a symbol table, it has to be a set. So you can just take a symbol table and throw away all the values and you have a set. So that's the idea in the book. And of course, we've said that the textbook uses iterable and comparable. Okay. It's really important. I think it's useful to know the JDK classes and understand some of their functionality. It's pretty impressive. Okay, so this is where to start. Understand this collection API. Okay. And you can see it is generic and it extends iterable. And don't worry about this fact that it extends serializable. That's a very technical thing that doesn't affect our use of it at all. So what do we get? We have the size, just how many items, whether it's empty or not, whether it contains a particular object. That should be a lowercase x. Now you notice that that's not the generic type, it's object. That means you can ask for an object of a different type. But adding is more, you can say, has a filter on it that you have to give the right type or it won't compile. Okay. But remove also uses the object. And then you can clear the collection out and you can iterate. You can get an iterator to go through the collection, and you can shift the whole thing over to an array, but you end up with an object array. So that's not too. It's only useful occasionally, but there's this is the better way to do it, usually anyway, which has a generic typing and allows you. But in order to use this one, you have to pass in an array of that other type. So maybe you don't have to worry about these to start with. These are the most important ones. Any questions on this?
Yeah, is collection just the Java word for data structure?
No, this is a real collection. I mean, you have a bunch of objects and you want to gang them together into a named group. That's what a collection does. So it's a particular data structure, or set of data structures really, but it's not the all possible data structures. There's nothing tree-like here, for example, right? You just drop things into this container with add, say, and check whether they're there by contains. Take them out if you want. So it's just a container. Of course, this is an interface, right? And that means we have to find one of those concrete classes so that we have a new something to get going. So for example, probably the easiest one to use is array list. This is a stretchy array collection. It's a very nice collection class. So let's suppose we want a bunch of bank accounts. We can just set up a new array of bank accounts. Okay. It's this easy. And now we have a my list, which is of that type. Okay. And of course, we could also call it a collection of bank accounts if we wanted to, but there's no harm in continuing to call it an array list. We'll find out that we can also call it a list. But we haven't gotten to that yet. Okay. So once we've done this, now we know my list is an object, and we know various methods it must have. It must have size, is empty, contains, add, and so on. How do we know that? Because it has to go by the collection interface. Okay. This is an implementing class of collection interface. And of course, it can have additional methods. And so it turns out it doesn't have very many interesting ones, but it does have a few obscure additional methods. Okay. Okay, so one thing we noticed is that this is a collection of with an item type, a generic item type. So it must, the elements of the collection must be objects. Okay. So we know we might like a collection of integers or a collection of doubles. So in that case, we just go over and use those wrapper objects. You know, use capital I integer, capital D double, and use the collection. Okay, so it turns out it's pretty easy to do. So it is pretty much a solution to the problem of holding collections. Okay. And this, of course, this business is also true of the textbook collection classes. They use a generic type. So there's a big parallelism here between what you were doing with in the textbook and the collection classes. Okay, now if you're a little unsure about the generic types business, you should reread page 122. Okay, so here's just a quick example of using an array list. Now it's maybe the simplest one to use. And these think the simplest kind of element to use is a string, because we know it's completely very nicely implemented by the Java system. Okay, so we have a new array list of string, and we throw a couple of pieces of fruit in it there, an apple and banana. And then, since this is a list, it has a get of I. So we can go through a simple iteration through I up to the size of the array. Now, I guess we haven't actually covered the fact that, get was not in the collection API, so this is not a perfect example, I guess. But since it's a list, it has get. So it's get of I. Okay, but we have other ways to do it that don't reach out to another fact. Now remember this, we can get an iterator out of any collection. If we go back and look again here, let's think about this. Every collection must provide an iterator when called upon by this iterator method. So you call iterator and you get back an object, and that object must be an iterator. Okay. So what is an iterator? Well, here's the interface for it. It has next and next, and also remove. Okay. So this is what you get back, an object that implements this interface. So once you have an iterator, then you can call next on it, next down through the collection. And you can see whether there's another one to go by calling has next. And you have an additional idea, additional feature that you can remove things as you go along. Okay. So this is, of course, used in, at least implicitly in the textbook, because they say something's iterable and that means it has an iterator. So, but in the book, they always make this no-op method, okay? So that's one little difference. When we go to the JDK, normally has a real remove, although there's some cases where it doesn't. Because if you look at the JDK documentation, that it says that this is an optional operation. So you're not forced to implement remove and still be, following the documentation. Okay, so let's rewrite that little program a little more legitimately using only things that are in the collection API. So what we do is we draw an iterator out of the collection by calling iterator. And that gives us an iterator string. And then we use the API of that iterator, calling has next on it to see if there's anything to see, and then next to get the next thing, and outputting the strings. And of course, we get back apple and banana. Okay? And then of course the has next fails, and the loop terminates. Okay, any questions on that? Now it turns out we don't often have to go through these 3 lines of code. It's more than necessary. So there's still another way. Okay. So we've just done this. We've got the iterator object from the collection, and then use its API. But we also have what's called the enhanced for loop that does this for us. Okay? It'll run the iterator for us. So if we say that collection implements iterable, we actually say that, then that means it has the iterator method, but then Java is willing to honor that in this other way of running the iterator for us. So all we have to do is use this syntax to do the for loop. So that's really neat. It's neat as a pin. Any questions on this? Okay. So, because it's a little bit complicated with iterable, iterator, and iterator methods, but hopefully you can straighten it out. So you can see the class is iterable, means the class has an iterator method, which returns an iterator object, which has next and has next as an API. Okay, and we've seen that that we can use the enhanced for loop as long as it says the class implements iterable. So you can see that we've seen this in the book, implements iterable on various APIs. They're collection classes. And that means that there is an iterator method. And so they figure that's sufficient documentation. So it's not listed in the list of methods. Okay. So it's there though. Okay, so this is normal. So but you might not realize it when you're seeing implements iterable. That means there is this other function. Okay, so you can see the APIs on this page. Any questions on that? Okay, so the collection objects are fully encapsulated, and this is also true with the textbook collection objects. It's the only reasonable way to do it. That means we can't see the inner workings of the collection from the outside, but we are allowed to get references to the objects that are in the collection. So now when we look at those collection objects, we would normally expect them to be fully encapsulated if they're, it's being used by a responsible programmer. But this is not enforced by Java, so they could be unencapsulated. So they could have public, instance variables, which I like to call fields. So please bear with me. So they still work fine. There's no dependence on encapsulation of the elements. But we're going to strive to use properly encapsulated objects for elements or for other things as well. And of course, so far we've just been looking at strings, which of course are beautifully encapsulated and implemented for us. Okay, so let's look at a little bit more ambitious example where we have bank accounts, which are a user-defined element. So here we have the array list of bank accounts. And we can loop through and get the balances. Okay, so as we go through it, of course, we have reference to elements in the collection. So you can see, at least for a moment, if you look at an element object, it's going to have a reference from the collection, because it's part of the collection, and it's also going to have a reference from BA, which is part of the program. So there's going to be two references into the same object. Okay, so this is how it works. Not just in JDK either, I guess I should say, in there. Elements in Java collections, I really should say, because this is also true of collections in the textbook or in anybody else's collections in Java. So we add an object to the collection by handing over the reference to the element object. Okay. So the object itself doesn't really disappear. We could still have a reference to the object while it's in the collection. So we call this object aliasing when you have two references to the same object. And it's well known to be somewhat dangerous. Another question? As you can see, that means there's two parties that have responsibility for this object. And so if one reference is used to change the object, the change is going to be cleared, obvious to the other reference holder. Okay. So in this case, you could change the deposit, deposit something and change the object in the collection. So you can see that these collections don't hide away the elements themselves. And this is true in anybody's Java collections. It's just the Java way to do collections. So we just have to be aware of it and know when it might be getting dangerous. Any questions on that? Okay, so we've talked about the collection classes, but we also need to talk about the map classes. And now map has its own interface because it's so different. A collection is like, a bag of things, but a map it's like a function going from one element to another. And so it just has to have its own interface. So for sets, we have hash sets and tree sets. And maps, we have hash maps and tree maps. And these correspond to about 6 different classes in the textbook. So it's just amazing that they don't want to give you an interface when they have 6 different cases of almost the same API. So we have then lists, stacks, queues, array lists, linked lists, and these correspond to the stack and queue in the textbook, but there's no general purpose list class. They talk about how to make lists without making a list class at the beginning, and then they go to the specific stack and queue, but not the general purpose list. I'm not sure exactly why they do it that way. But anyway, we want to look at the general purpose lists that are available in the JDK. And then, of course, the priority queues. So I guess this is probably a good